Hi, good day everyone. My name is Muhammad Imam Sudrajat, a PhD student from the University of Twente in the Netherlands, and also affiliated with BRIN, or National Research and Innovation Agency of Indonesia. And today, as the representative of other authors, I want to present our research with the title of Conducted Electromagnetic Interference Risk of Electrostatic Discharge on Medical Equipment. And in this research, we take a case study of conducted emission noise of an infant incubator. First of all, the aim of this study is to analyze the effect and the risk of electrostatic discharge, or we call it ESD, on the conducted emission noise generated by the medical equipment. And in this study, we will more focus on the noise at the low frequency range. And so different from the previous approach that only sees ESD from the immunity aspect, this study investigates the effect of ESD from the point of view of the conducted emission. And in this study, we take a case of an incubator as an equipment under test to represent the medical equipment. Why we choose the infant incubator? It's because the infant incubator are usually touched by the medical healthcare, and it has a metallic structure which increase the probability for the occurrence of ESD. And in this study, we observed the conducted emission at the phase line, and from our investigation, we found that the ESD exposure on the surface of infant incubator can cause a current spike and a wideband spectral conducted emission noise. And for medical application, the appearance of this wideband spectral noise will be very risky because it also appears in the low frequency range where the observed biological signals are accessed on there. So this is our table of contents. In this presentation, I will divide into several sections. First, I will explain the background and motivation of the study, then followed by a short explanation of electrostatic discharge, particularly in healthcare facilities. And after that, I will explain our investigation method or our measurement technique to observe the effect of electrostatic discharge on conducted emission, and then followed by the result that we obtain from this investigation. And in this study, we will also explain the two results. The first is the effect of ESD on the level of a current spike, and the second is the effect of ESD on the level of conducted emission noise. And the last part is the conclusion. So this is the background and the motivation of our research. As we know that in hospital, many medical equipment are interconnected one to each other. And in this case, when a medical equipment has high electromagnetic interference noise, it can disturb the performance of another equipment and lead to erroneous data or malfunction of the another device. Moreover, most of the medical equipment work in low voltage and low frequency, which is intended to detect human biological signal. But by this design, it make the medical equipment is very sensitive to any disturbance. For example, the electroencephalogram that work at frequency below 100 Hz or electrocardiogram that work at the frequency below 250 kilohertz. They are working in the very low voltage in the range of microvolt to only millivolt order. So it means if any noise appears in this operating frequency or in this low frequency range, the unwanted noise can disturb the signal processing or the quality of the recorded signal. And in this case, the noisy signal from the source can be coupled to the victim through the conductive or the radiative mechanism. Talking about the ESD, in a hospital, ESD can happen when the operator or patient touch the medical equipment. And in this case, the accumulated static electricity at the operator hands discharge suddenly to the medical equipment, and it causes a high level current flow through the conductive material of medical equipment, which by nature, this current will find the lowest impedance to the ground. And several studies have investigated the effect of ESD on the medical equipment, and they show that the ESD has a significant impact on the medical equipment performance, such as it cause artifacts or a malfunction. And since ESD is destructive to IC or a semiconductor device, most of the previous research only focus on the immunity aspect. On the other hand, in theory, ESD also can generate a broad spectral noise, even only in several milliseconds or even faster. It's because the ESD have a short transient and high dividity uh, on its ESD event. Unfortunately, none of the previous study observed this behavior in real application, and particularly related to its effect on the low frequency. So, this is our investigation method. The observation is focused on the effect of ESD on conducted emission on medical device, and the ESD test setup is referred to IEC 61000-4-2. And in our study, the ESD tests are applied on 9 different points that represent the accessible part of the infant incubator. Um, the point are 3 points at the handle of the right side, and 3 points at the handle of the left side, and 3 points located at the front of the incubator. And in this observation, we applied 5 levels of the ESD test. There are 6 kilovolt, 8 kilovolt, 10 kilovolt, 12 kilovolt, and 15 kilovolt. And at each level, we applied 10 ESD shot or ESD tests on the AUT with a 1 second delay between each test. And to observe the effect of ESD on the conducted emission level, we monitored the current at the baseline using 2 different probes. One current probe is used to measure high frequency signals, and a second current probe to measure the low frequency signals. In this figure, we can see the waveform of the current that is monitored at the phase line. As shown in this figure, there are 10 current spikes that have the timing same with the ESG event. And in this case, the high voltage SD event at the source of the incubator, resulting a high current spike that then propagates to the conductive structure of the incubator and flow to find the return path to the reference. Furthermore, we will analyze the effect of ESD on the different test points to the level of current spike. As we can see in both figures, ESD tests at different points, resulting in different level of current spikes, and ESD tests with a higher level tend to produce higher current spike, except ESD in point 0.5. And the point with the highest effect is the point number 4, followed by point number 6. And as can be seen in the right chart, ESD at the point 4 with a 15 kilovolt, resulting in a very high current spike with a level of more than 13 ampere. Uh, this high current spike happened due to this point has closest and lowest impedance path to the power module. And this high current spike should be considered since the current spike at the phase line is not good for the hospital power quality and can disturb the performance of other medical equipment. On the other hand, there is a point where ESD has the lowest impact. As I mentioned before, it is the point 0.5, and it seems there is no significant effect on the level of the current spike. due to power point 5 has higher impedance that make ESD current difficult to flow from this point. And in this case, there is no increasing level of the current spike even if we increase the level of ESD, which means the point 5 is the safest point to touch or get into contact with the infant incubator. Furthermore, in this figure, we can see the effect of ESD on the spectrum of noise. These figures show the time and frequency domain of the conducted emission at the phase line. And as can be seen on this figure, there are two different type of electromagnetic interference noise. The first is the harmonic noise, and this noise appears continuously as a result of system non-linearity and the system switching mechanism of the incubator when the incubator controls the temperature. And the second noise is a broadband noise that occurs due to the electrostatic discharge, and it appears only when the ESD shot are applied to the incubator. And since this noise also appears at the working frequency of medical equipment, it has the potential to interfere with the performance of medical quality in monitoring biological signal. And of course, this risk should be considered or mitigated properly to avoid a false diagnosis. Last but not least, in this conclusion section, I will recap the aim and the important finding of this study. So the aim of this study is to analyze the effect of electrostatic discharge on the emission of medical equipment. And in the study, the investigation and analysis were performed by simultaneously combining the ESD test and conducted emission measurement. And the investigation indicates that the highest average current spike on the phase line occurred when ESD was imposed on the closest point to the power module due to its low impedance path to the power module. And furthermore, the 3D spectrogram analysis showed that a wideband conducted emission noise due to ESD exposure was also detected in the low frequency range. This is due to the natural characteristic of a short spike current with microsecond duration in ESD that create additional conducted emission noise flow on the power network. And assessing the risk of ESD only from the susceptibility perspective, of course, is not enough, particularly when we implement the IEC 60601-1-2 risk management standard. And in this case, the ESD effect on the conducted emission noise should be considered as a noticeable risk. So we hope by considering the risk assessment, we can improve the quality of healthcare facility and healthcare performance. Thank you for your attention. If you have any further question, please do not hesitate to contact us. Bye bye.